My name is Francine Adams, and I will be your presenter. This video will introduce information architecture, discuss the origins, the history, definitions, and some of the basic principles. Let's break information architecture down to the fundamentals. What is information? According to Wikipedia, one might consider data, information, and knowledge synonymous. However, data in its abstract state has no meaning. The Dama Dictionary of Data Management defines data as, quote, facts represented as text, numbers, graphics, images, sound, or video.
No hills in Toronto.
No hills at all. You can
Flat,
see the edge of the...
Data is the raw material used to create information. Information has a dependency upon data such that it's not plausible to discuss information fully without discussing its dependent relationship to data. What is architecture? The Dama Dictionary of Data Management defines architecture as the organized arrangement of component elements to optimize the function, performance, feasibility, cost, and or aesthetics of an overall structure. So what then is information architecture? R.E. Willis of the University of Texas at Austin Graduate School of Library and Information Science credits, quote, Richard Saul Wurman as the first to coin the phrase information architecture. Wurman was a man trained as an architect as well as a graphic designer, author, editor, and publisher of numerous books on the presentation of information in a variety of fields. Wurman, says Willis, defines information architecture as the science and art of creating an instruction for organized space. Wurman parallels information architecture problems of gathering, organizing, and presenting information as closely analogous to the problems an architect faces in designing a building. Wurman defines the information architect as 1. The individual who organizes the patterns inherent in data, making the complex clear. 2. A person who creates the structure or map of information which allows others to find their personal paths to knowledge. 3. The emerging 21st century professional occupation addressing the needs of the age, focused upon clarity, human understanding, and the science of the organization of information. The information architect may or may not be engaged in all of the data management functions, but to be successful he or she must be fluent in them. Data management is a function that is also known as a high-level business process. It consists of the planning and execution and oversight of policies, practices, and projects that acquire, control, protect, deliver, and enhance the value of data and information assets. The mission of data management is to meet the data availability, quality, and security needs of all stakeholders. The goals are to understand the information needs of the enterprise and its stakeholders, to capture, store, protect, and ensure the integrity of data assets, to continually improve the quality of data and information, to ensure privacy and confidentiality, and to prevent unauthorized or inappropriate use of data and information, to maximize effective use and value of data and information assets. Data management has 10 functions, which will be covered in this video. They are data governance, data architecture management, data development, data operations management, data security management, reference and master data management, data warehouse and business intelligence, document and content management, metadata management, and data quality management. Data governance is accomplished most effectively as an ongoing program and a continual improvement process in the information architecture. Data governance is focused exclusively on the management of data assets. It is at the heart of managing data assets. Here, data governance is depicted as the management roof over other data management functions. Ideally, a good data management framework, overseen by data governance, will be the foundation for the information architecture. The data management body of knowledge is an agnostic, holistic framework centrally managed from within the enterprise by data governance. Every enterprise should have a data strategy driven by the enterprise business strategy and used to guide all data management activities. It's going to be within the data management functions where the quality of information will be determined in the information architecture. Data stewardship. Data stewards manage data assets on behalf of others and in the best interest of the organization. Data stewards are appointed to represent the data interests of all stakeholders, including but not limited to the interest of their own functional departments and divisions. They must take an enterprise perspective to ensure the quality and effective use of enterprise data. Data governance is essentially a high-level executive data stewardship. Executive data stewards are senior managers who serve on a data governance council. Coordinating data stewards lead and represent teams of business data stewards in discussions across teams and with executive data stewards. Coordinating data stewards are particularly important in large organizations. Business data stewards are recognized subject matter experts working with data management professionals on an ongoing basis to define and control data. This graphic depicts the data management organization's governance, stewardship, and services. On either side of the graphic are your gatekeepers. In blue are data stewardship, data governance, and on the right in green is data management services. Since we're on the right, let's begin with the executive administrative performance responsibilities. The CIO is your data management executive. He or she oversees data management service organizations and is responsible for data architects, data analysts, database administrators, data integration specialists, and business intelligence specialists. Tying those together is the Data Governance Office and Data Stewardship Facilitators. To the left in the pyramid are your data stewards. The Chief Data Steward is on the enterprise level and oversees the Enterprise Data Governance Council and the Executive Data Stewards, who may be responsible for divisions and programs such as divisional governance councils and program steering committees. They in turn oversee the coordinating data stewards and also the next level of subject-oriented data stewardship teams, which includes the business data stewards and other subject matter experts. These services collaborate to manage the functions of data management shown below in the black text, and we will talk about those in a bit more detail. As mentioned earlier, executive data stewards are responsible for data governance. They oversee the data management functions beyond data governance. Let's take a look at those next. The goals of data architecture management are to plan with vision and foresight in order to provide high-quality data, to identify and define common data requirements, and to design conceptual structures and plans to meet the current and long-term data requirements of the enterprise. The activities in this function, shown in the blue box, include understanding enterprise information needs, developing and maintaining the enterprise data model, analyzing and aligning with other business models, defining and maintaining the data technology architecture, the data integration architecture, the data warehouse BI architecture, the enterprise taxonomies and namespaces, and the metadata architecture. Data development is carried out by business data stewards who define data requirements and specifications for data analysts and architects to organize into logical data models. Coordinating data stewards then help the data architects integrate those specifications, resolving differences in names and meanings. Data stewards validate physical data models, database designs, test and convert data, train and identify data issues. The information architect must understand the data operations function. Business data stewards will define requirements for things of such importance as data recovery, retention, performance, and negotiate service levels. They will also help identify, acquire, and control externally sourced data. The domain of data operations includes the performance and reliability of the database underlying the information architecture. That includes backup and recovery in the event of loss of data in any circumstance. The information architect should be intimate with data security. Business data stewards provide security, privacy, and confidentiality, identify and resolve data security issues, and assist in data security audits and classifying the confidentiality of information in documents and other information products. The information architect will want to be aware of external regulations and internal data privacy concerns in ordering up information and providing accessibility in the information architecture. To summarize, the ultimate goal of data security management is to protect information assets in alignment with privacy and confidentiality regulations and business requirements. These include stakeholder concerns. Organizations need to recognize the privacy and confidentiality needs of their stakeholders. That includes their clients, patients, students, citizens, suppliers, or business partners. Government regulations. Government regulations protect some of the stakeholder security interests, but some regulations restrict access to information, and other regulations ensure openness, transparency, and accountability. Proprietary business concerns. Each organization has its own proprietary data to protect, ensuring competitive advantage by intellectual property and intimate knowledge of customer needs and business partner relationships is an asset. And finally, legitimate access needs. Data security must also understand the legitimate needs for data access. Reference and master data management. Business stewards control the creation, update, and retirement of code values and other reference data, define master data management requirements, and identify and help resolve master data management issues. Reference and master data management may or may not be exclusive in your organization. However, there is no one term that encompasses both. Reference data management is controlled over the defined domain values or the vocabularies. That includes control over standardized terms, code values, and unique identifiers, the business definitions, the business relationships within and across the domains. While master data management is control over master data values, consistent, shared contextual use across systems of the most accurate, timely, and relevant version of truth about essential business entities. In all organizations, reference data exists in virtually every database across the organization. Reference tables, sometimes called code tables, link via foreign keys into other relational database tables, and the referential integrity functions within the database management system ensure only valid values from the reference tables are used in other tables. Some reference data sets are just simple two-column value list pairing a code value with a code description, such as shown here in Table 8.1. The code value taken from the ISO 3166-1993 country code list is the primary identifier. The short form reference value that appears in other contexts. The code description is the more meaningful name or label displayed in place of the code on screens, drop-down lists, and reports, often known as the business name. Note that in this example, the code value for United Kingdom is GB, according to international standards, and not UK, even though UK is a common short form. Some reference datasets cross-reference multiple code values representing the same things. Different application databases may use different code sets to represent the same conceptual attribute. This is important because the information that's going to be presented to the user may be coming from different applications, which are sitting between the data and the information. To continue, a master cross-reference dataset enables translation from one code to another. Note that numeric codes, such as the FIPS, state numeric codes, shown in Table 8.2, are limited to numeric values, but arithmetic functions cannot be performed on these numbers. Some reference datasets also include business definitions for each value. Definitions provide differentiating information that the label alone does not provide. Definitions rarely display on reports or drop-down lists, but they may appear in the help function for applications, guiding the appropriate use of codes in context. Data warehousing and business intelligence are the responsibility of business data stewards who provide business intelligence requirements and management metrics and identify and help resolve business intelligence issues. The information architect will want to be knowledgeable in data warehousing and business intelligence functions. The activities include understanding business intelligent information needs, defining and maintaining the data warehouse and BI architecture, data warehouses and data marts, BI tools and user interfaces, processing data for business intelligence, monitoring and tuning the data warehouse processes, BI activity and performances, while delivering accurate information and displaying it beautifully in graphics, dashboards, and other business intelligence tools may be pretty exciting. The lion's share of the work in any data warehouse business intelligence management effort is in the preparation and processing of the data.